so test the hypothesis for a right-tailed alternative at 5% significant value. So we are going to test the null hypothesis equals 0, and then the alternative is equal to or greater than. So we do know that our R equals 0.8793 from the previous page. And then our sample size is 15, and our degrees of freedom would be 13 because n minus 2, which would be 15. So here it is, 15 minus 2 equals 13. So let's see. We find the critical value using the critical values table at 13 degrees of freedom on a one-tailed and 5% level of significance. So the critical value would be plus or minus 0.441. And since our R is 0.8793, we can conclude that 0.8793 is larger than our critical value of 0.441. So R is significantly larger, and the line may be used for prediction. The alpha line may be used for prediction. The line best fit of y on x, we're going to punch into this equation here. And we're just trying to find the x and y slope. So basically, pyx equals our xy times x times y over our observed squared times x. So basically, what we get is 1932.897 over our 10.6104, which would give us our 182.17, which is gonna be our slope. And then so basically, to test the hypothesis, we have to use this equation here. Y minus y equals, or the sum of the y minus the sum of y equals b times y times x times x minus the sum of x. So we need to test that. We need to find b, basically. And how we're going to do that is we're going to punch in the numbers that we were able to find. So we basically want to use our slope, and basically we just punch it in here. 297.6 equals the 182.17, which we got from here, and we're going to multiply that as our x minus, we know it's 38.36 because we got that from, where did my thing go? Here we go. We got it from here, 38.36, and then, or really essentially from the sum of x over n. That's where we got the 38.36. So, sorry, I'm a little disorganized. I've done this like 4 times. Minus that 38.36. So we take our slope, which is the 182, minus, we punch these in, and we get our y-intercept of negative 4011.4412 plus our slope. And then, and to estimate y, so the last question says, fit the line of best fit y on x. Use this model to estimate y when x equals 18 weeks. So basically all you would do, since we didn't, you just plug in 18 for x. So we're going to use our intercept plus our slope times 18, because we're going to just punch in 18 for x. And then once you punch all that into the calculator, you get negative 732.3812 at 18 weeks. So